Hello students, today we'll be continuing with the process of integration by parts. In the previous video we had taken some applications of integration by parts in finding the integrals of logarithmic functions and all the inverse trigonometric functions. Today we'll take yet another very important application of the process of integration by parts, that is the application of this in solving the integrals of the type e raised to the power of x times the sum of two functions, that is fx plus its derivative. Okay, so let's see how this helps us. Now e raised power of x times fx plus f dash x dx, suppose we call it I. Okay, so when you solve it, you can split this as e raised power x fx dx plus integral of e raised power x fx dx. So I becomes equal to, now here this is f dash x dx. Now I becomes equal to, if you just take this first function and we follow I late. Okay, it's a product of two functions. Now here this is the exponential function, so no matter what kind of function this fx is, exponential function will always be treated as the second function and the other function as the first, because exponential function always comes in the end, and so we treat this as the second function and this as the first function. Doing in this manner, what we get is I will be equal to the first function, that is fx, into integral of the second, that is e raised power x, minus integral of derivative of the first function into integral of the second function dx, and this we carry down as it is, that is e raised power x f dash x dx. So writing it again, so we get e raised power x fx minus, and here also writing e raised by x first, we get f dash x dx plus e raised by x f dash x dx. Clearly this function gets cancelled with this one and we are left with I is equal to e raised by x fx plus a constant, and this gives us a very important result, that is, if whenever we are given a function of the kind e raised power x times fx plus f dash x into dx, we will directly write the answer as e raised power x into fx plus a constant. Okay, now let's do the some questions based on it. So let's again continue with our exercise 7.6, question number 16. Now we have I is equal to e raised power x sin x plus cos x into dx. Now clearly sin x and cos x are derivatives of each other, but here because of the presence of plus sign, we will only consider fx as sin x and f dash x will be cos x, because if we had taken fx as cos x, then the derivative would be minus sin x. So if there was a presence of minus sign here, we would have taken fx as cos x. So fx has to be so chosen that it exactly falls into the category of fx plus f dash x. So now clearly this is of the form I is equal to e raised by x fx plus f dash x into dx, and whose integral is e raised by x fx plus a constant. Therefore the given solution would be e raised by x and fx is sin x plus a constant, which can be written directly. Now let's come to question number 17. Now question number 17 says that the function is x e raised by x upon 1 plus x whole square. Now in such a function, though it's a product of two functions, one function is x upon 1 plus x whole square and the other one is e raised by x but still it is not in the form of what we want to use it. Let's try if by making some changes to the form of this function, if we are able to convert it to the to this form, that is e raised by x times fx plus f dash x. So let's write this as, see, we want the denominator to be 1 plus, the denominator is 1 plus x whole square. So using a hint from here, let's write this x as 1 plus x. So if I am writing it as 1 plus x, means I have added 1, I have to subtract 1, and 1 plus x whole square is as it is, e raised by x is as it is. Now we split the numerator, we can write it as 1 over 1 plus x minus 1 over 1 plus x whole squared, e raised by x dx, which is of the form fx plus f dash x into e raised by x dx, where fx is 1 upon 1 plus x and f dash x is minus 1 upon 1 plus x whole square. So clearly we get the answer as I is equal to e raised by x into 1 upon into fx, but fx is 1 upon 1 plus x plus a constant. So directly, without having to calculate this further, by only writing it in a form where we can apply this result, we can get the direct answer of this question. The same way we can try out the other questions also, like let's say if we take up question number 18. Question number 18 is e raised by x 1 plus sin x over 1 plus cos x into dx. Now here what we can do is, let's rewrite, or let's replace this cos 1 plus cos x. We know it's a standard result, so we can rewrite this as 2 cos squared x by 2, and this 1 is as it is, and sin x also can be written in terms of x by 2 as 2 sin x by 2 cos x by 2 into dx. So simplifying it further, we get e raised by x times 1 upon 2 sec squared x by 2 plus this 2 gets cancelled, cos 1 cos gets cancelled, and we are left with tan of x by 2 into dx. Now if we put fx as tan of x by 2, we get f dash x will be half sec squared x by 2, which is this function. So clearly I is in the form of e raised by x f dash x plus fx into dx, and whose result can be directly written as e raised by x fx plus c, but fx is tan of x by 2, and hence the result is I is equal to e raised by x tan of x by 2 plus a constant. So in the same manner we can do similar questions, like question number 19 is a direct one, where one function is here. Question number 19 is a direct application of this. Directly we know that fx here is 1 upon x and f dash x is minus 1 upon x square. So directly we get I as e raised by x into fx, which is 1 upon x plus a constant. Now question number 20, we'll have to make a slight change, and so which is to be dealt with in the same manner as question number 17. Now what is given to us? X minus 3 e raised by x over x minus 1 whole cube. Now again, taking the hint from the denominator, that is x minus 1 whole cube, we want to write the numerator in the same form. So I can write it as x minus 1 minus 2 upon x minus 1 whole cube. We put this together and e raised by x is as it is, dx is as it is. Now splitting the numerator, we get 1 upon x minus 1 whole square minus 2 upon x minus 1 whole cube whole into e raised by x dx, which is again in the form fx plus f dash x, because if we put fx as 1 upon x minus 1 whole square, we get f dash x will be minus 2 over x minus 1 whole cube, and therefore we get I is equal to e raised by x into fx, which is 1 upon x minus 1 whole square plus a constant. So on the same lines we can do the rest of the questions, and more so questions which are similar to this form, that is, which involve exponential function and along with that fx and the and its derivative. Thank you.